This robotics video is on line tracking using a line tracking sensor. The picture we're showing here is the VEX line tracking sensor. This is one of them. Sometimes we see them two side by side or even three side by side. So what is a line tracking sensor? The name's slightly misleading because we could use it for other things besides line tracking, but that tends to be one of the bigger uses of it. So what it is, first of all, it's an analog sensor because it gives set readings based on how it's made. And it shines an infrared light, so we don't see that light when it's on. It shines an infrared light and records how much that light bounces back. So it shines light on a target, and then basically it has a light receiving element that tells us how much light comes back. You could certainly trick these things. If you took a light source and just shine the light source into the sensor, it would say, oh my God, all the light's coming back, right? So we do have to understand that it doesn't know where the source of the light's from. It just assumes it's the light that it gave off bouncing back to it. And then it gives off values based on how much light comes back. The lower the value, which is a little weird, but the lower the value means more light has reflected back to it. The higher the value, less light shines back to it. And really, to get a feel for these values, you really need to use your debug and try it out on the different surfaces, and we'll talk about that a little more. Okay, so it's not really a great color detecting sensor. There are sensors that detect color. This really isn't that. Can you do it? Some you can. I'm not saying you can't. I've seen people, they'll pick up blues versus blacks and things like that, but it takes a lot of tweaking, and then if it works one day, there's no guarantee it will work the same the next day because of the ambient lighting, right? So there are some issues with it. It shines a very specific type of light, infrared, and detects how much that bounces back. So white surfaces and red surfaces tend to be pretty much the same because a white surface will reflect red light. A red surface will reflect red light. That's why it's red, right? So it has hard times distinguishing between those. But then the colors that are kind of on the opposite end of the spectrum of red really are a lot like black. So black reflects nothing. Well, blue, that reflects blue, but there's no blue light being shined by the sensor, but it doesn't reflect red. So this is something we could talk about in person, but really, there's a certain range of colors that it's going to recognize as black or very close to black, and then there's other colors it's going to recognize as white. So it's not a wonderful thing for detecting color. It really will just detect percentages of this infrared that bounces back, right? Which could help determine colors, but I wouldn't count on it. So I said it once already, right? It's recording, basically there's a light source in it and it records how much light comes into the sensor, right? And by the way it's made, it's assumed that light came from the light source built into the sensor, but it doesn't have to, right? If you're in a bright room and there's a lot of light and that's bouncing off the field that the robot's on, well, some of that light's going to go into the sensor. It's going to make the values even higher than normal. If the room's exceptionally dark, it might make it lower than normal. So you write a code, and usually you have a threshold value, which is my integer, but integers become very useful for here, right? So you set an integer equal to that, what's black, what's white division line, which we'll talk about here in a second. And then you don't have to go through the code every single day, or even if someone just turns off the lights or opens a window shade, right? You don't have to go changing everything, right? Because all of this outside light definitely matters, right? In competition, especially like Lego competition, where teams use this lights a lot, we let teams come on first thing in the morning and check their values with respect to what they expect them to be, right? And if someone has issues, then we try and get them on later in the day. And this happens in all competitions, really, because if you're using something like this, it can vary as clouds come in or the room darkens or lightens, right? So it's things that you have to be careful. And it's much easier to put an integer in and say, the value of light is this, and then only change that and have that integer, be written throughout the code, than to keep going through every line of code and finding all the places you have to change values, right? So we've talked about integers, and integers become very useful. So this threshold value, is kind of the dividing line. It's where we want the cutoff to be, right? Let's say that black light is 2,000 and white light is 400. Well, where do we put the cutoff? Do we put it at 401? Well, no, because if the ambient light changes a little bit, maybe that doesn't work anymore, right? So we kind of want to find that value that's halfway in between the white light reading, the white surface reading, and the black surface reading, right? So which means you got to use your debugger. You're going to have to set up your code, and before you run it, right, you have it connected and you download the code and the robot's just sitting there, what you tend to do is you tend to put the sensors over white, see what they read, put the sensors over black, see what they read, right? And then find the halfway point between these two things. And again, if you make this as an integer, you do this every day, and then you've changed it. Now, on virtual worlds, I don't think there's going to be too many differences, right? Because it's a perfect, computer-generated world, and there won't be these issues. But in the real world, absolutely there is, right? So making an integer, establishing a threshold value, all important things. Right? It's not worthwhile just to guess, right? You should always check the white value and the black value and find halfway point between those. All right, so how do we mount them? Well, we mount them very close to the ground. And we mount them very close to the ground because we want to minimize the effects of ambient light and we want to maximize the effect of the internal infrared light source, right? So 1/4 inch to 1/8 of an inch off the ground. We can't have it touching the ground because then the light will never really get to where it needs to go. But we're talking about a couple pennies in between the sensor and the ground, and that's really about it. So 1/4 inch to 1/8 of an inch off the ground is ideal. If you're using it in a different way, yeah, you can mount it differently. But then again, you have to understand, right? The farther away it is, the less the internal light has an effect on what's going on, and the more it's just how much light's getting in there, which could have absolutely nothing to do with the ground that's underneath it. So here's a quick example in virtual worlds of a robot following a line. So if I run it, we can see that it's going to run and it kind of corrects itself over and over again so it stays on the line. This is a 3 sensor, and we'll talk about how we can do it with different sensors. Right? I don't know if this is going to actually get to the finish line. It doesn't, but that's okay. But this is a sensor. This is the use of multiple sensors that make this happen. Now, there's 3 different ways that I see that we could do it. And I shouldn't say that. You could always add more sensors and make this a better system. But this can be done with 1 sensor. And if it was done with 1 sensor, let's see. All right, so here's 1 sensor, right? Ideally, you just have 1 sensor, which I'm represented by this orange box on the robot, or on this kind of cheaper version of a line follower robot. It's right there. So let's see, right here's our line follower, or I got it on this table here. And here, we can use it a couple different ways. And like I say, a line follower really, it's to give it a name, it's telling you what its main function is, but it doesn't really tell you what it's doing, right? But we know what it's doing. It's measuring the amount of light that bounces back. So I don't have to use it to follow a line. I could use it to carry an action when a robot crosses a line. Let's say this is the field up here, and like this is my finish line, and I have a robot and I want it to come to a stop when it crosses the finish line. Well, 1 sensor is going to work fine for that because it's going to keep driving. And as soon as it sees black, it says, okay, we're done. I can stop here, right? Or I could turn, or I can grab something, right? You can carry out function. So if it's like driving until it sees dark, or if it's on dark and it's driving until it sees white, same difference. Well, then 1 sensor works fine, right? Because it's going to pick it. We can use it for following lines, but then that tends to be a little more work. You have to understand the type of line that it's going to follow. If it's following the exact same line over and over again, well, then I think 1 sensor could do that job. But it's limited, right? It's not going to be able to have too many corrections built into it, right? So basically the commands would be, okay, is the sensor see black? If it's yes, drive straight, right? Does the sensor see black? No. Well, then what's got to do? You've got to write some type of program where it spins or searches for that black line. Look at the picture, say, oh, all it's got to do is turn left slightly. Well, that's great, but if it falls off this side, Well, now it's got to turn right slightly. And because it's one sensor, it doesn't know which way it left, right? It just knows, hey, I don't see black anymore, I see white. So you would have to come up with something, right? You'd have to come up with something that sweeps back and forth until it finds it. It might slightly turn right and then more to the left and then more to the right and more to keep expanding until it finds it, something like that. Or if you know that, it's following a trail that's always like this, so it's always going to leave going this way, then maybe it always just corrects to the left, right? So, there's cases where this could work. There's cases where it's going to involve a little more of a complex searching method to get it back. And the other hazard I see with these is there's plenty of times where here's my line, the robot leaves this way, and it searches and it searches and it searches and it searches and it searches. Then it finds a line and it starts following it. Sure, but now it's going the opposite direction, right? These things happen all the time where in the process of searching, it spins itself all the way around before it finds a line, and now it follows it going the wrong direction. So while some places do it just fine, usually it's a known line that this works well on, or it's a limited process, right? This robot here is pretty cheap. And can it lose a line? Sure, it can lose the line, right? But it's pretty good at following a straight line. So you kind of have to think about the situation. I'm going to ask you to try and do this, but just understand that. All right, let's see. So the second way that you could set this up is with two sensors. Now, I'm a fan of two sensors. I prefer, when I do this myself, to set this up that way. There we go, two sensors. And two sensors follows the line well. And again, we could use it for other things. We could use it for the uses that one sensor are, but there's cases where we just simply don't need two sensors. But it's not bad to have two sensors if it's detecting things on the right side or the left side of the robot, right? So if I had the robot here, and then there was something over here, right? And I put a sensor at this point. I put a sensor here, I put a sensor here. Well, then when this one hits it, say, okay, not only do I see it, but I know it's on the left side, right? If this one found it, say, well, not only do I see it, but I know it's on the right side, right? So if I had two sensors and they were looking for things that they're driving over, that it might help determine the orientation of the robot. But on the flip side, we could also use it for following a line. Now, this has less limitations than using one sensor, but then we could argue when we look at three sensors that three sensors is still a faster process. Once it finds a line, it just follows it easier, and that's all fine. But here we kind of have some basic operations. First of all, we have the black line in between the sensors, so neither sensor actually sees orange. So if it's already between the line, and this is the one place where there's an issue with it, but if we know that the line is already straddling the line, then if this sees white and this sees white, well, then it knows what to do. It says, okay, well, neither one of them sees the line, so it must be in between. Let's just go forward. Now, the correction is easier because it says, okay, my right sensor sees the line, so what do I have to do? I've got to turn left. Now my left sensor sees the line. Now my right sensor sees the line. Now my left sensor sees the line. Now what I got to do? I got to turn right, right? So this makes it fairly easy to correct. It corrects every time it sees black. This could certainly run into issues if we have something that takes a very steep turn or something like that. But for the most part, this serves the purposes fairly well. And like I say, this is my preferred way of doing this, is just to use two sensors because the code is a little simpler, and the limitations aren't so great that it's like, oh, this can't work in a lot of cases. So it works well. But the last option that we list, and really we can go past that, is using three sensors. And we could expand this thought to 5 sensors or 7 sensors or any odd number of sensors. The more we spread out sensors, the more control we're going to have on where we are and how to correct ourselves. And here it's kind of simple again. If the middle sensor sees black and the other ones see white, well, then that's go straight. If these two see white and this one sees black, well, then we must take a left turn until this one sees black again, right? And just to back it up, right, what tends to happen with this one is when it loses the line, it's here or here, it tends to not drive straight very much. It tends to kind of shift this way, and then shift this way, and then shift this way, and then shift this way. And it does just fine following the line, right? But it kind of weaves back and forth. So it's really not corrected until either one of these sees something. So in the process of going straight, if it kind of veers off to the side, it's going to keep correcting as it's going straight. Not a tragedy, just saying that's what it does. This one tends to avoid that. If the middle one sees the line, well, it knows that it just should go straight. If the setup is these two see white and this one sees black, it can correct itself to the left. If the setup is this, these two see white and this one sees white, it could correct itself to the right. And we can have some other variations. I didn't draw every single, thing that it could happen. What if the road took a turn like this and it was like a 90-degree turn? And this one saw black and this one saw black. Well, you could do these things, right? Because you have more input, you could simply provide for better corrections. And that works out well too. And then if it turns out at this point here where you have, hey, none of the sensors see it, well, then you've just simply lost the line. Maybe the line's gone, or maybe that it corrected so much it actually flung it off there. And that's part of, your motor speeds and things like that. You could absolutely, make it do a left turn so drastically that before it even has time to check again, it's way over here, right? The front is way off the line, right? So this kind of has another value where it says, okay, none of us see black. Now we've got to go through some type of sweep in motion to find the line again. Or that's when we stop, right? Maybe the line ended, right? The line ended right here. And now when none of the sensors see black, we can say, okay, well then that's it. You're off the line. Go do the next thing, right? So, the more sensors we add, the more input we have to work with, right? And I did 4 examples in my pictures, but really there's probably 6 examples or even 7 examples, right? We could have a line go like this, and for a moment of time, they all see black, right? We could say, we could have a turn like this. We could have a turn like this, right? So we could certainly have situations where we would expect 2 sensors to see colors at the same time, or all 3 or none, right? So it just allows for more variation in programming, and it allows you to allow the robot to think about more sensors and adjust to different situations that can pop up. Okay, so that is line tracking sensors and line tracking in a nutshell, right? You've done work with integers. You've certainly done work with sensors before, so these things aren't going to be too hard to deal with. And I will put up the challenge.